Hello, CDKL5 Brasil. My name is Anna, and I work with the Lulu Foundation and with CDKL5 Spain, helping make new treatments for CDKL5 deficiency disorder. And I'm here to tell you about all of the news in CDD from the labs here. And the most important news have happened this year. And that is that you know that there are many different epilepsy syndromes. There are hundreds of epilepsy syndromes. And there's this big conference that happens once a year and that I like to go to called the American Epilepsy Society meeting, AES. And every year we hear about all of the new medicines for epilepsy, but it's always the big epilepsy, focal onset, generalized seizures. That's the normal epilepsy. And sometimes we also hear about the syndromes like Dravet and Lennox, but it's always the famous syndromes. People don't hear enough about CDKL5. But the last year, in December, everything changed because we have this giant exhibit stand by Marinus about ganaxolone approved for CDKL5 deficiency disorder, at least approved in the United States. But that meant that thousands of doctors and scientists that go to this conference now go to hear about CDKL5 deficiency. And now every doctor needs to learn about it because there is a medicine to give them. So this was such an important year with very important news. And right now in Europe, we got even better news because ganaxolone is now also approved in Europe. And I hope that little by little, it will get to more and more countries and more families will be able to have ganaxolone, because having one drug approved is not obvious. Only 5% of rare diseases have a drug. And now CDKL5 is part of the 5. Big news, big year, but there was more happening this year. So in the next minutes, I want to share with you all other news that have happened around treatments for CDKL5, including a few things that might happen later this year. First, let's remember how CDD happens. It happens because the brain doesn't function well because a protein called CDKL5 is missing. And that is because the gene needed to produce that protein, the gene CDKL5, is mutated. So this, as a scientist, means very different ways that we can try to fix the disease. We could try to make the brain function well with it, and that means treat the symptoms. Or we could try to put the protein back so that you don't have the symptoms. Or we could try to fix the gene. And there are many different ways we could do this. We could try to give a new copy of the CDKL5 gene to the brain so it can make CDKL5 protein. Or we could try to fix the mutated one. It's fine if it's mutated, just fix the mutation. Or in girls, we could go after the second copy of the X chromosome and make the body read that copy. So I'm going to walk you through all of these different treatments in development and the news in this year. But the big message is scientists around the world are working on all of these options. All of these options. Everything is being tried. And that is very good news. Let's look at the first ones, the one for the symptoms. The main symptom that we're trying to fix now in clinical trials is the easy symptom, which is epilepsy. The first trial for treating epilepsy in CDKL5 just got approved, and that is ganaxolone. That was approved in 2022, so last year in the United States, this year in Europe. I hope it will get to more and more countries and to more and more people. It acts through the GABAergic system, so GABA, like benzodiazepines, but different. And after this one, there is now a clinical trial going on in many countries with a drug called fenfluramine. And fenfluramine is a drug that has been already approved for other 2 diseases, Dravet syndrome and Lennox-Gastaut syndrome. But there was also a very small study in CDD, and it looks so good that they've started a global study. And I don't know if it is in South America, but this is a global study right now for CDKL5. Different way of working in the brain. This drug works on the serotonin pathways and helps make the seizures not spread through the brain. Another drug in clinical trials is soticlestat, also for the symptoms. And soticlestat works also different. This one works on neuroinflammation, so the brain inflammation. And this drug was tried in small studies in Dravet, in Lennox-Gastaut, in CDKL5, and in another one. And it worked in all of those. And the company, which is Takeda, decided to run the big study only in Dravet and Lennox, but because many kids with CDD have Lennox, they really want these kids to participate in the study as Lennox. And they want them to participate because there is very good data from the small study that was done in CDD. These were 12 kids, and on average, the seizure reduction, and that's here, was 30%. That does not look a lot, but that's like an excellent in the big trials. 30% is the average. That means that for some of them, it was much more. And more importantly is this, 92% of the parents that had kids in the study thought that their children improved a lot on the treatment. That's most of them. So it looks like soticlestat could be helping much more than just epilepsy. The families that were in the small study that were all in America are very positive. And I will encourage you to think about this study because it is happening in Brazil. There are many clinical sites that will be accepting patients. It looks online like they're not yet accepting patients, but here's the list. You can see it. You can probably find it online. And I will encourage you to talk to your doctor if your child with CDD has enough symptoms of Lennox, including drop seizures, seizures where they end up falling. But that was symptoms. How about the biology? How about having the protein CDKL5 in the brain? This is something that is done for other diseases that are similar to CDD. If your protein, in this case CDD, is an enzyme, those are proteins that act on other proteins. Often scientists can make the protein in the lab, put it in liquid, and add that liquid to the brain of kids like this one. These pictures are from another disease called Batten disease. And in Batten, the children are born with a mutation on a gene that is also the type of gene that acts on other proteins in a protein. So it works for other diseases. Why can't we do that for CDKL5? Well, the reason we have had a lot of problems doing this for CDKL5 is that CDKL5, the protein, yes, it is an enzyme, but it's an enzyme that is never in liquid. It's not in the liquid in the brain. It is inside of the neurons. And because of that, it's really not happy in liquid. So the protein CDKL5 looks very nice in the neurons, but when we try to make it in the lab, it just gets all clamped and it's not active. So it doesn't work. And this has been a problem for many years. But there is one scientist that is trying to find a solution for this, and that I think she might find a solution for this. And her name is Maria Luisa Tutino. She is a mom of a girl with CDKL5, and she's also a scientist. And in her lab, she makes bacteria produce proteins. And she has made bacteria produce CDKL5. And that CDKL5 is actually fine in liquid. And if it is fine in liquid, maybe we can use it to then put it in the brain and use it for enzyme replacement. So I have a lot of hopes in Maria Luisa. The Lulu Foundation gave her a grant this year that is funding to try to advance this project. And if one day we can have this type of treatment, it will be because of people like her. So this is advancing this year. Another thing that is advancing this year is gene therapies. So fixing the gene problem, trying to get a gene therapy for CDKL5. If you remember from other presentations, the way that we do gene therapy in science is getting a virus like the one for the flu that will infect you. And instead of having the virus, and that's the top drawing, infect you and give you virus DNA and make more virus, what we do as scientists is get the virus, take out the virus DNA, put CDKL5. So now when the virus infects you, it will give you the gene for CDKL5, and that is a gene therapy. There are several gene therapies in development, at least 3, but there were more, in development for CDKL5. And this is from a year ago when we saw presentations at the big gene therapy conference by 3 different companies with 3 different gene therapies for CDKL5, using them in mice. That's before clinical trials. So the news from the last year is that in November, we heard from the company Ultragenyx that they are getting ready to go to clinical trials. They said that in 2023, next year, they were going to sit down with the regulators, like the FDA, and ask them, here's all our data with our gene therapy, can we start clinical trials? So this is something happening this year. And in March of this year, we heard from Majid Jafar, who's the founder of the Lulu Foundation, Lulu is his daughter, that there is another company that is a partnership with the Lulu Foundation and the University of Penn, making another gene therapy, also for CDKL5, and they are also talking this year with regulators. That means that this year, 2023, it's a very important year for gene therapies in CDD, because this is the first year when the two companies are sitting down with regulators and asking, we have all of this data, can we have our gene therapy start clinical trials? Clinical trials will likely start later because you need the approval first, but this is a critical year where we could be making that transition to being able to start clinical trials. Very, very important. In that conversation with regulators, they will ask, have you done enough work in animals for us to think that this therapy is safe? Have we done enough work to know the dose that we need to give? Those are all in animals. But there is also one question that needs clinical data, and that is, how will we know that the therapy is working? That means not just counting seizures, but more. Do we know what else to measure in CDD? Because there are a lot of different symptoms. And because of this, it's so important to be in projects like the registry, so for families to sign up to this, so we can have so much data about how CDKL5 deficiency looks normal, that we know if the therapy is making it better. So this is very important for that. Other projects, so those two projects are very close to starting clinical trials because they already have the gene therapy working well in animals, and they are talking to regulators to start trials. Behind that, there are other types of gene therapies. For example, this one. This one is looking at the second X chromosome to try to reactivate it. So in women, we have two X chromosomes, but one of those, it's not being read by the body, it's a ball. And that's why I use this image, it's a ball. That means that if this one has a mutation, you have a problem, but we could try to read this one and have a good copy. To try to do that, scientists are developing a gene therapy to open the second copy. It will only work for girls, and it's still in a phase of work in mice. But the good news of this year is that the leading scientist working on this strategy just got last year $1.4 million to try to develop this gene therapy to open up the second X chromosome. This is a lot of money. This is a lot of money for a rare disease. So this will help move this forward a lot faster and hopefully more successfully. Another news from the last year is another type of gene therapy. In this case, trying to fix the mutated copy. This is a kind of CRISPR, where scientists are trying to fix the mutation. And this is working already in cells. And we heard this at the forum by David Liu, the scientist developing it. And this is also advancing. It will also look like a gene therapy. That means a virus that you put in the brain and will now fix the gene. And these are more years. This one still need more years before they're ready for clinical trials. So I've told you a lot, and what I just want to summarize now is the main messages of what have we learned in the last year for CDKL5, and that is, first, scientists around the world are trying all of the different options to try to fix CDKL5 deficiency. We're working on the symptoms, we're working on the protein, we're working on the gene with many different strategies. Second, big year. Now we have the first CDD drug in Europe, it's already in the States, hopefully we'll reach more countries. Many rare diseases don't have a drug. In the last year, we have the first drug. This is such a big news. And last, 2023 is a very important year for gene therapies in CDD. This is the year companies are going to regulators and telling them, here's our gene therapy, here's all of the data. Are we ready to go for trials? Big, big, important year, a lot of progress. Very good year with progress. I want you to remember that making new medicines is actually very hard, but the CDKL5 community always says we are in this together and things are moving and they're moving ahead because we are all working on this together. Thank you so much for having me this year to tell you about all of this news. And I hope to see you next year and tell you many more news. And maybe we'll have clinical trials with gene therapies. Until then, have a wonderful day.